this video is for the 2023 exam 2 and the multiple choice section. So the extended response will be in another video. So let's get started. The first multiple choice question from the exam. So the amplitude and the period, that's what the question is asking us to find. So that is our amplitude. So it's always an absolute value, which is a half. And the period, it's a sine function. It's 2 pi over n, which is n is the coefficient of the x, so which in this case is 3. So it's 2 pi over 3, which is that option. All right, the second question. So for the parabola with equation y equals to ax squared plus 2b x plus c, where a, b, c are all elements of a real number. The equation of the axis of symmetry is, so this is a year 10 content. So this is what you have seen in year 10. So negative b over 2a. So the b is the coefficient of the x, so the linear one. So negative 2b over 2a. So the coefficients cross. So that leaves us with negative b over a. So which is a has to be the correct option. Okay, so this is a function, two functions. So they are both continuous over the given domain. So the domain of the sum, so that is where the two functions basically intercept. So the easy way I would actually say is just to draw a number line showing the given domain. So in this case, negative 2 there and 3 somewhere there. And 5 further down here. So if I draw, so that's going to be closed, and I'm going to use a different color. So for negative 1, which is somewhere there, and that's going to be an open circle, and that's a closed circle just up there. So where the sum only, this is the section where they overlap, so that must be that option. So it's going to be negative 1 to 3, which is open circles, which are open circles. All right. Okay, so this one here, consider the system of simultaneous linear equations where below. So the parameter k. So the first thing is just to put it in a linear format, which is y equals to mx plus c. So we make the first equation, which is y1 equals to k plus 5 over 5 minus k over 5x. That's my y1. So my y2, and my y2 should be, I'll take the whole lot out. So that's going to give me negative 4x over k plus x. So we want, so in infinitely many solution is when m1 equals to m2 and c1 equals to c2. And that is what we need to find out when that's the case. So we solve for x. So what we could do is, because since the m's, this is m1, so we equate the two m's and solve for k. So that could be achieved using the CAS, which is a lot easier. And so that's our negative k. So that's going to be negative 4 over k plus 1. So get the CAS out, solve for, so many 3, 1. So that gives me, what is that? So that was negative k, if I'm not, no, negative k. No, negative k over 5, isn't it? Negative k over 5, that was what it was. Negative k over 5. All right, negative k over 5. Oh, this other one. and negative 4 over k plus 1. Negative 4 k plus 1. K plus 1, comma k. So that gives us k has to be negative 5 and 4. So let's write it down, those numbers. So k value is negative 5 or 4. So the next thing we need to find out is, and this, so we need to find out, well, this doesn't have a c value. Well, the c value is 0. So we need to find out, work it out, when k equals to that. So if I put 4 there, so negative 4, so negative 5 I should say, when k equals to negative 5, my m1, my y1 will be, well, if I put, that's going to be 0, and I put 5 there, negative 5 there, so that gives me x, isn't it? So y2, if I do the same thing for y2, so if I put, there's going to be negative 4, substituting negative 5 there, so that's going to be x again. So that's going to be m1 equals to m2. How about when k? So we want to find out what happens when k equals to 4. If I put y1, I get 4, that's going to be 9 over 5. And that gives me negative, well, negative's already there. 4 over 5, x. So my y2 do the same thing again. So if I put 4 there, well, if I put 4 there, it's going to give me negative 5, negative 4 over 5. Well, the m's are the same. M's are m2 equals, but c1 does not equal to c2. So this is no solution because m1, but it's only infinitely many solution when m1 equals to m2. In this case here, this is c equals to 0. So m1 is actually 1 and m2 is 1. So the only option that is, the correct option is k equals to negative 5. Alright, which of the following function has a horizontal tangent? So if I actually differentiate all of this, well, it's going to be the same sort of thing. And, well, I can't solve for x in any of this. Well, the only one that gives me, if I differentiate a value of x is this option here. Alright, let's differentiate that. So I'm just going to say shift minus. So the x there. And that was, just get down there, x to the power of 4 over 3. Well, that just change the calculator setting. Just going to keep it exact there. So if I actually solve for that, well, that could have been done in one go, but nonetheless, we solve for x. So x equals to 0, and if I sub it in back into my original equation, which is this one here, that gives me 0. So the only option that gives me a value of x is that one there. So option D. Alright, the next question here, suppose that the integration from 3 to 10 f of x equals to c, from 7 to 10 equals to d, the integration. So now we need to find out from, so this has been changed because the upper bound is actually they swapped. So now this means it has to be a negative. So if I use if I draw a line there and I write from 3 to 10 and I say from there to there, from 3 to 10, the integration is actually c, and from, well, that must be 10, isn't it? I made a mistake there. That has to be 10. That has to be 10. And we also know from 7 to 10 is, just going to use a different color, is d. From 7 to 10 is d. So this is what the question is asking us, this bit here. So that must be c minus d. But then again, the terminals has been changed, so that's going to be a negative. So that means from 7, well, 3 to 7 must be negative. We put the negative because the lower bound is up, the upper bound is down. So that means negative C minus D, so which gives us D minus C, which is that option there, up there. All right, I hope that's clear. All right, let's move on to the next one here. So the next question is, it's a composite function. So with a restricted domain, so we need to bear in mind. So we're going to use the domain, the input. So this one here, so let's rewrite this. So this is the same as saying f of x, f of g of x, I should say. Well, we're going to use that domain because the range, in other words, the range of the inside, the input should be a subset of the output. Well, the range of g of x has to be a subset of f of x domain. All right, so if I input that, so that's going to give me that's what I get. So if I get the derivative of that, and I get the domain, because the question is the domain of the derivative of that, what is it? So we just use the cast, much easier. It's just on here. So the domain was, so shift minus x. So we want to get natural, oops, not that, control, that's better. Our function was square root of x minus 1. Alright, square root of x minus 1. So we want the domain of this. So we're going to say domain of the answer, comma x, given that it is less than 1. Well, it's less than 1. So that's what we get. Because the domain, yep. So that gives me option C has to be the option. Alright, a box contains an n green balls and m red balls. A ball is selected at random and its color is noted. The ball is then replaced in the box, and in 8 selections where m and n are not the same. What is the probability that a green ball is selected at least once? Well, the probability of actually at least 1 means the probability of 1 minus the probability of selecting none, which is 0. Well, the probability of selecting none means you are not selecting a green ball, so you're actually selecting a red ball. So, which in this case here is going to be 1 minus, it's going to be 1 minus 8, select none. So the probability of actually selecting green, which is 0 green, would be n over m plus n to the power of 0. So m will be the complementary plus n to the power of a. Well, this whole lot is 1. Well, yeah. And we have that has to be 1 again. So the whole answer has to be m over n plus n to the power of 8, which gives us C. Alright, now a function f of x is given that, so the value of a for which the function is continuous and is smooth at x equals to 2 pi. Well, the best option is actually to sketch this, because that actually gives you a visual representation of what the piecewise function is about and where it is. Well, where it forms a sharp corner, so that is not going to be a continuous function. Let's have a look at that function there. All right, now, so we have, so control doc. So we had tan x over 2 so x over 2 so that was restricted, so we have to restrict our domain. So that's going to be 4 2 was that 2 pi? Oh, yeah, 2 pi. 2 pi. Press enter. I'm gonna have to also put the other one here, so which is the sine one. This is sine a. So just to make sure you put a times in between the variables, the a and the x, times x, and also that one was restricted as well. What was that? 2 pi. 2 pi x to 8 and you press enter. Create a slider, yes. Alright, now we need to try all the options. So because the question is asking the value of a for which the function f of x is continuous and smooth at x equals to 2 pi. So if we start when x equals to -2, which is, that's the beauty of the slider, we can just click the value of a and we're just going to try the first option as to be -2 there. Well, definitely that's not a continuous function because that forms a sharp corner. So it cannot be option A. Alright, let's try the other option, which is -pi. So if I put -pi, which is down there, over 2, what do I get? So that's going to be discontinuous. That's not going to be the option again either. So if I try this with -1/2, because that's going to be the next option, which is -1/2. Well, that looks like it's actually continuous and joins. What happens if I make it a positive there? So let's have a try. So let's get rid of the negative. Well, it's a sharp corner. That's not a continuous function. Alright, that's not going to be. How about 2? If I put 2 there and change the value of a to 2, let's have what happens. So that's not an option. So the correct option is actually C. Alright, and let's have a look at the next one here. A continuous random variable x has the following probability density function, the value of k such that k is less than 0.35. So this is, we use the solve. And if I actually solve for the first section of this, so let's have a look. So that's going to be, alright, so let's actually get our solve. It's going to be menu 31, and we are integrating from, what was that? From 1 to k, 1 to k, 1 to k, and that's going to be, the denominator was 20 if I'm not wrong. Anyway, what was it? That was x minus 1 d of x, the whole lot equals to 0.35 comma k. Oh, that is what we get, the option. So the -14 plus 1, and 14 is square root of 14, negative square root 14 plus 1. So the only option is B, because we don't have the -14, square root of -14. So the only option that's in there is actually that one there. All right. Let's move on to question 11. Two functions f and g are continuous and differentiable for all x is an element of a real number. it's given that f and sub -2 equals to -7 and so on. So now the gradient of the function, so this definitely we have to use a product rule because we are multiplying, so that requires us to use the product rule. So the derivative, so y prime will be f prime times g of x plus f of x times g prime. All right, so now it's just a matter of actually substituting the value. So that is f prime, so that's going to be 3, sorry, that's 3 times g of x, well, g of x is 8, plus f of x, well, f of x is -7, put a bracket, times g of x prime when x equals to -2 is 2. So that gives me 24 minus 14, which is 10, which is option E. All right, question 12. So this one here is asking us the mean. The probability mass function for the discrete random variable x is shown below. The maximum possible value for the mean of x is. So we need to get the mean first, and well, we multiply x times the probability distribution. -1 k squared plus 0, so that's going to be 0, that won't make any difference. So 2 out, so -k squared minus 4k plus 1. Well, that gives me -k squared plus k minus 2k squared minus 8k plus 2. Well, if I collect the like terms, so that gives me the mean as to be, what is that? So that's going to be -3k squared. So that's going to give me -7k plus 2. The maximum possible value for the mean of x is, well, the maximum possible value, well, we could actually, this one here, the maximum possible value, well, to get the maximum, we can actually get the derivative of this and actually solve for k to get the maximum of the f max. Well, f max of that, what is that one going to be? Maximum, what was it? K, -3k, -3k squared plus, or minus actually, minus 7k plus 2 comma k. And if I say this as to be Control C, and I say g of x, so over k, I'm just going to say k, and I Control V, and I say g of k when k equals to -73/12. Well, none of the options are 73/12. Alright, how about when k equals to 0? When k equals to 0, the maximum possible value of the mean. So k equals to 0, which our mean of x, well, everything, well, it's going to be 2, but with the maximum possible value. Doesn't make sense. Alright, now the following algorithm applies Newton's method for using a loop with 3 iterations. And so now this one here, my f of x is actually, that's my f of x, which is down there. The derivative is that. So now, and well, this one is basically using the Newton's method. What if I actually do this? And I use my class, and let me just define that and just say, well, can I actually define this and just call it f of x, given that x cubed plus 3x minus 3, and I'm just gonna call h of x or g of x is the derivative of f of x and I'm just gonna say when x equals to, what was that? The first initial, so when x equals to 1 minus f of x when x equals to 1, g of x, and I'm just going to make a decimal down. Alright, I'll take it. So now the answer to that is the same thing again, because that was the first iteration, so we need 3 iterations. F answer, G answer, so that was the second one, so this is the third one. Alright, F answer, G answer, that's the third one here. 0.81773, so which is C. Option C looks to be promising. Alright, let's move on to the next question. Question 14. The number of tangents. So a polynomial has the equation y equals to that. That's a quadratic function. The number of tangents to this curve that passes through the positive x-intercept is. Best thing is to draw this one here. Alright, let's get the cast. Boom. Alright, that one was x into bracket 3x minus 1. 3x minus 1. Open another bracket. What was the other one? X plus 3, x plus 1. X plus 3, x plus 1. That's error. So whatever it is, times. Yep, okay. So what is the question asking? So that's a quadratic function. The number of tangents to this curve that passes through x-intercept is, well, the x is actually positive in that quadrant there. So that means, can I change the window to make it more like this one here? Well, it's gonna keep it -10 maybe, and it's gonna be negative, and also it's gonna give me a better view. Okay, can I still use quadrant maybe? Yeah, just there to make it a bit more. Just gonna make it a little bit bigger. Box. Oh, that's better. Alright, let me just sort of put it more. Oops. Alright, box, first corner, second corner. Oh yeah, that's what I need. Okay, now I'm just gonna sort of capture pointer. Alright, that's better. Oh, that's beautiful. Okay, now, well, a tangent line is actually a line that actually touches the graph outside. So this is going to be, if I put a horizontal line, that's going to be one tangent line. And there could be another line that goes this way here. That's going to be a 2. There could be another line that goes this way here. That's 3. 3 lines. One the bottom, one the side, another other side. So 3. Alright. Alright, so question 15. Let x be a normal random variable with a mean of 100 and a standard deviation of 20, sorry. Let y be a normal random variable with a mean of 80 and a standard deviation of 10. Which of the diagram below represents the probability density function for x and y plotted on the same axis? Well, we can actually plot this, or we can also use the process of elimination anyway. Well, it's not going to be the anyway, they're just the same. They cannot be the same because the standard deviation of 20 is actually a bit wide spread, so you have got a bigger spread, whereby this is not, this doesn't have it. Well, this has got a small spread. So let's actually, we could actually sketch using our CAS by saying, by using this 1 over sigma square root of 2 pi e to the power of negative a half, then x minus mu, which is the mean of sigma, then the whole lot is squared. So we could use this. So now we know the standard deviation has to be, well, we could graph both and see which graph actually looks like that. So let's do that. I'm just going to get a new page. Alright, now, so in this new page, I'm just going to grab the first one. So I'm just going to say, so 1 over 10 times square root of 2 pi. That's what the formula is. 2 pi times e to the power of negative a half times, open a bracket, so x minus, so that 10, the 10 had a 80, 10 and 80, so that's going to be 80 over 10, the whole lot is squared. Yep, so we're just going to play around with the window setting. Alright, we're just going to set this one as to be 100. Alright, this one here, we're just going to make the steps of 10. Let's do it that way. Let's make this one here 0 because the bell curve, the y, doesn't pass the x-axis. And we're just going to make this one here as to be 0.5. 0.5. And we're just going to say the y scale has to be 0.01 smaller. So that gives me, so it's actually say zoom fit. Nice curve. So we're just going to do the same thing again. Can I just copy this? Just going to try to copy that. Let me just copy this and just change. Control C and I press tab. Tab, Control V, Control V. Yep, beautiful. So the other one was 120. The mean is 100 and the standard deviation is 20. So I put the 100 and that is 20. And I make this one here has to be also 20. Press enter. So that actually gives us, so all we have to do is we're just going to go back to the paper and look at the one that looks like similar to this graph. All right, out of all this, well, the only option that looks like the one we have is actually option A. All right, so which is actually a straightforward question. All right, option A. All right, now the next one here. Well, we could also use the cast this one here as well too, so it's not a hard question either. All right, so we know this, so it's going to be g of x will be e to the power of x minus 1 divided by what f of x is. You can just use the cast down there. If I use the cast, what do I get? So I'm just going to say e to the power of x, I think x minus 1 was what it was, if I'm not wrong, squared over x minus 1. Is that what it was? Let me just double check. X minus, yeah. Press enter. Whoops. I actually get that one has to be, let me just change the setting into exact. All right, let's do it again. All right, so that's what I get. All right, now this is, well, none of the options look like that. So we could actually say menu 3, 2 to factor. We're just going to get this bit there. We're just going to factor it. Under that is what? X minus 2. X minus 2, x minus 1, so option B. Option B is the correct option. All right, let's move on to the next question here. All right, question 17. So a cylinder of a height h and r radius is formed from a thin rectangular sheet of metal of x length and y width by cutting along the dashed lines shown below. All right, so the volume of the cylinder. So the volume of the cylinder is pi r squared h. So now we need to find out what h is. So we know that that is, well, the radius is r. So the diameter must be 2r. That's 2r. So my h value must be x minus 4r. Okay, so r also, well, y equals to the circumference, which is 2 pi r. So r must be y over 2 pi. So now we have, because we have to put the volume in terms of x and y, so we have to make sure all our variables are x and y too. So the h is x minus 4 into bracket y 2 pi. Well, that's 1, that's 2. So that's going to be my h value is going to be x minus 2y over pi. So the next thing I have to do is just sub it in. So my volume is pi r squared. So my r is y over 2 pi. And the whole lot is squared x minus 2y over pi. Just multiply that. So it's going to be pi x minus 2y over pi. And that gives me, what's that? 4. That's 1 pi. So that's going to be y squared over, well, that's going to be, what's that? 4 pi. And if I expand this, what do I get this, my volume to be? So the volume will be, expand that, by x y squared minus 2y cubed over 4 pi squared, which is b, has to be our option. All right, consider the function negative a pi, negative a pi and a pi, f of x sine a, where a is a positive integer, and the number of local minima in the graph y equals is always. So this is also, well, I would actually use the cast. So let's use our cast. Alright, new page. And that one was sine a times x. So we just have to restrict our domain. Negative a times pi x a times pi. Alright, a times pi, a times pi. What do I get if I change the a value and make it 2? Let me make it 2, because it's a positive integer. If I make it 1, what do I get? Make it 1. Make it 1. Oops. When a is 1. How about when a is, well, it's going to be 1. How about if I make a is 3, for example? It's getting more local minima. What happens if I make a, because what do they say, man, these guys? The number of local minima in the graph y equals to f of x is always, well, it's not 2 for, well, it's not 2, and it's not 4, because we actually changed the a value, and none of those options, because we're just going to get to our 10, well, 1, 2, 3, 4, 5, 6, 7, 8, 9, it's 9. It's actually, this is squaring actually, so let's do this one here. It's like squaring the a, isn't it? Because that's 9. So let's say 4. What happens if I make it 4? Will it make it 16? Oops. So I'm going to say zoom fit. Whoops, that's too many. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Do we have more? Let's say, alright, now let's actually count. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. It's actually squaring, isn't it? 16. Definitely the a is squaring. Which is that option? Yep, beauty. Alright, now find all values of k such that the equation x squared plus 4k plus 3 times x plus 4k squared minus 9 over 4 equals to 0 has 2 real solutions for x, 1 positive, 1 negative. Okay, now, so this is beauty. So let's actually use our cast. So cast is the best friend in exam 2. Just going to use a new window. Menu, solve. So that one was x squared plus 4k plus 3x plus, I think it was 9 over 4. And the whole lot equals to 0. We're solving for x, comma x. Alright, now we solve for x, so now we need to solve for k. Menu 3, 1. So the question is asking us k, where k is actually greater than 0. That's when we get 2 solutions. Where k is greater than 0, comma k. Oops. Where k is greater than 0, that's what we get. How about when k, when this other bit, because menu 3, 1, and I do the other bit, this other section, when k is also greater than 0, comma k. That's going to be what? -4. What's that? Oh, -y. Okay, so this one here, Control C. Control C. We'll just do this one again. Well, that one was supposed to be negative. Alright, so Control V. So just make it negative. Enter. So that's going to be, so let's solve. That was we solve for x, so let's solve for y. So is that the correct one? X for x. Let me just do it again. X squared 4k plus 3. Oh, I left this bit here. This bit is missing. Okay. Let me do it again. Must have done something wrong, some typing error. Alright, now, so that's going to be 4k squared. 4, actually, it's 4k squared, so minus, yeah, that's minus, so let's do it again. So x squared 4k plus 3x, 4k squared minus 9 over 4. So let's see what they get. So now that's what I got. And then you 3, 1. So I'm just going to solve for k here. When this whole expression is greater than 0, we're solving for k. So that's what I get. Negative 3 over 4. So which is D? Option D is actually what we got. All right. The last question from this section is So we have we're actually finding the largest interval of x values for which f of g. So let's get this one here, the largest value, f of g. All right. So we sub it in. What do I get if I sub down here? So that is going to be sine x. So we're just going to replace the x with sine x plus 1 over square root 2. Well, that's what it is anyway. If I compose that, and if I solve for that, so I'm just going to compose another one again. I'm just going to use different color to compose it. So this time g, the f is input, whereby, all right, so is that the correct one? So which one is actually the input one now? Sine now. It has to be the sine, isn't it? Sine. Yeah, sine. Sine. It has to be sine. That's right. It has to be the sine this time. Sine. Sine into bracket. Yeah, so this one here. Plus 1 over square root of x. Alright. And the whole lot has to be less than 5. And this one has to be less than 5. We're actually solving. So let's see that largest x. So let's use the solve key. Alright, menu 3, 1. Was that natural log? So I'm going to do the first one. Natural log. Sine x plus 1 over square root of 2. The whole lot is actually less than 5, comma x. If I actually say this, if this whole thing, put it there, and I say when n equals to 0, what do I get? That's 0, and that's 0, and that's 0. And I just press enter. So that gives me that. But if I sketch that, what do I get? I get this one here. If if I put a number line, well, x cannot be a negative square root 2 over 2, so that's basically what they said. And the highest is actually 5 pi over 4. So you're going to do the same thing here again with this one here, this time with a sign. And if I was to graph this, well, negative that, so 5 pi, well, it's actually roughly, and the highest we could get is 5. All right, let's do the other one as well to see where the two intersect. So this is basically, that's going to be open circle, another open circle there. All right, so let's do the other one as well. All right, the other one was sine. All right, now let's do the same one here. So menu 3, 1, oops. Menu 3, 1. And this time it's going to be sine the natural log. Sine bracket the natural log of x plus 1 over square root of 2. The whole lot is less than 5 comma 5 comma x, I should say. So that's going to be, well, can I actually say comma, well, this whole lot has to be greater than negative a half, because that negative, how about if I actually say this bit here, it's actually greater than the maximal domain, which in this case the maximal domain has to be, well, greater than negative 1 over square root 2, given that x is actually less than, well, given that x is actually less than 5. What do I get? This number. And I make this one as to be 0 and 0. Oh, this is time consuming, this one here. Make down 0. Press enter. So that's a decimal. Negative a quarter. Well, roughly negative a quarter was that one. So that's going to be negative 0.7. 0.771. I think that's going to be negative a quarter, will be somewhere there. 0.2 something. That's the other one. 5, up to 5. So let me just use different color. So now from there to there. So the only bit they overlap, well, the only option that's in there is actually this one here, which is only this bit here, this bit there, which is this option. Negative is the same as negative 1 over square root 2, which is that option there. All right, that's the end of the multiple choice.